Hi, good morning to everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, we are going to discuss about the basic components of electric circuits in this video lecture series. Come, let's get into the topic. So, what is actually, before going to discuss about the basic components of the electric circuits, first we should know what is electric circuit. So, electric circuits are closed loop or path forming a network of electric components where electrons can flow. Electrons can flow is nothing but of current. So, this path is made using electrical wires and is powered by a source like a battery. The start of the point where the electrons start flowing is called the source, where the point where the electrons leave the electrical circuit is called the return. So this image shows the very basic component of a simple electronic circuits, where here there is a battery and load is there. So load is here is a light bulb, and there is a switch to make the circuit on and off. We have a switch. So connect the wires to the bulb and connect one end of the wire to the battery. Notice what happens. There won't be any change in the bulb, but when you connect the free wire to the battery and complete the circuit, you will notice the bulb will start glowing. Therefore, the circuit must be completed for the current flow. Circuit must be a closed path, or it should be it's like a loop, so that only the light will glow. And a simple circuit which comprises of power source, conductors, switch, and load. Again, the cell is a power source. What is load? It is also termed as the resistor. It is a it is a light bulb that lights when the circuit is turned on. Conductors, they are made up of copper wires with no insulations. One end of the wire is connected to the load, to the power source, and another one of the wire is connected to the power source back to the load. Switch. It is a small gap in the circuit. There are various types of switch. A switch can be used to open or close the circuit. And there is next term is AC and DC. That is alternate current and direct current. What is that? So alternate current is nothing but by the name itself you can see there is an alternation in the current. That means if you plot the graph for the AC, we have x-axis and y-axis. So the current will be varied. Alternatively, like positive cycle, negative cycle, like that. So that's why it is called as a alternate current. So that means that with respect to the time, there will be variations occurring in the each and every time period. But in the case of direct current, there won't be any change. It will be constant. That's why it is called as a direct current. You can see the graph in the slide. So the both the AC and the DC are given by the graphical representation. So here DC is a constant one. So with respect to the time, the magnitude is constant, whereas here AC, with respect to the time, that magnitude value, either current or voltage value, will get changing. And the next thing is resistor. What is resistor? So resistor is nothing but of a it opposes the flow of current when it's going beyond the limit. So that is actually easily depicted in this diagram. So volt, which is nothing but of electromotive force, which pushes the ampere. Ampere means it is a current. But above this no diagram, one dot termed as ohm, which controls the amp going that side. So that means that it's a resistor. So what is inductor? Inductor stores energy in a magnetic field when electric current flowing through it. So this is called an inductor. And what is capacitor? So capacitor stores energy in the electric field when voltage applied across it. So this is the capacitor. So both capacitor and inductor both are used for storing the energy, electrical energy. But the storage method is different for capacitor and as well as the inductor. When you going for the capacitor will be having two conductor, which is two parallel plates. It's a conductor which will be placed in a closed proximity. So on between the empty space, there is a dielectric material. There won't be any connection. So because of this, there will be some force will be occurring. That force is called electrostatic field. So in the capacitor, the charge will be stored in the form of electrostatic. But in the case of inductor, the electrical energy will be stored in the field of electromagnetic field. That is the difference. So these are already some basic components of the electric circuit. Thank you.